Problems of optimization under uncertainty are characterized by the necessity of making decisions without knowing what their full effects will be. This video will familiarize you with frontline systems tools available to help you tackle uncertain decision-making situations. We'll see how to build and solve stochastic optimization models. If parameters of your optimization model, such as an objective coefficient or constrained right-hand side, are subject to uncertainty, they have to be represented in such a manner that their effects on present decision-making can properly be taken into account. We'll call these uncertain variables, and in Risk Solver platform or Analytic Solver platform, we'll use the uncertain variable dialog to define and quantify them with a probability distribution. Let's look at some stochastic optimization applications. Please notice that in these examples, time is almost inevitably involved because exact knowledge of the future is what most typically is lacking. In generation of electrical power applications, for example, an electrical utility has to decide each day how much power to produce to meet uncertain demand, which depends on weather. In operation of reservoirs, systems of water reservoirs and their connecting flows have to be managed in a reasonable manner for drinking water, flood control, recreation, and the protection of fish runs under climate uncertainty. In inventory management, supplies of retail goods or spare parts must reliably be maintained given uncertain demand and the costs of restocking. In portfolio selection, investments must be made in stocks, bonds, foreign currencies, and the like, given uncertainty in future prices. And in airlines and car rental applications, the fleets and personnel must be managed given uncertain demand, weather, and ground conditions. Here is a project selection or capital budgeting problem. It has uncertainty, it has integer variables, it has an objective of maximum total cash flow, and an investment constraint. It has distributions for cash flow of successful projects and also distributions for whether a project is a success or not. Let's see what happens if we solve this problem with Risk Solver platform. But just before that, let's verify how the solution method matters. First, let's turn off the guided mode. Then, go to the Platform tab and change the Solve Uncertain model to Simulation Optimization. And now, let's change the engine to Evolutionary. Let's hit the Optimize button. After a while, maybe about 30 seconds, we will get a solution, and we don't know whether it is optimal or not. Now let's go to Platform tab and change it to Automatic, and Engine tab and make it to Automatically Select Engine. Let's hit the Optimize button. It immediately solves in a fraction of a second. And most importantly, we have a proven optimal solution. It solves this problem using a linear solver without trying to go through all the explanations. Risk Solver platform has automatically analyzed this model and determined that the robust counterpart can be applied. This is just one example of the kind of results you could get from Risk Solver platform. Although helpful, simulation optimization doesn't scale to large models, and the solution time increases exponentially with model size. However, for linear optimization models with uncertainty, we can apply solution methods that take advantage of model structure. These methods, such as stochastic linear programming and robust optimization, make it practical to solve large-scale problems. There are many business situations that allow wait-and-see decisions. Simulation optimization doesn't allow this. However, you can use stochastic programming and robust optimization to model these problems.